Welcome to All Sorts Podcast, the show where we, take deep dives into all sorts of fascinating topics. And today we're diving into React signals and how they're kind of changing the game when it comes to state management in React apps.
Yeah, it's definitely a big step forward, I'd say. Beyond just swapping out your use states and your use reducers, we're really talking about like a fundamental change in how we think about state and how that state impacts performance.
I'm intrigued by this. From what I've been looking at in these articles and code examples, it seems like signals are like these independent little units of data almost, like they can update specific parts of your user interface without setting off like a whole chain reaction of re-renders.
Yeah, that's a really good way to think about it. Signals actually exist outside of like the normal React component lifecycle. So they're not really bound by the same kind of rules that govern your components, which gives them this kind of unique advantage when it comes to performance optimization.
So are you saying that instead of re-rendering a whole component, even if like a tiny bit of data has changed, signals can like pinpoint exactly what needs to be updated and make the change in like a very surgical way?
Exactly. Like, imagine with traditional state management, changing state is kind of like flipping a light switch in a room. The whole room lights up, even if you just wanted to like illuminate a small corner. Signals are more like having a spotlight. You can direct the light precisely where you need it.
I see. And do you have any like hard numbers about these performance gains from our sources?
Oh, yeah, absolutely.
All right.
One of the articles we looked at highlighted a pretty complex application where they introduced signals and saw re-renders reduced by like over 70%, which is a pretty significant improvement in perceived performance. Users reported that the app just felt much snappier and more responsive.
70%, that's huge. That's not just a minor tweak. That's like a game changer, especially for applications that are dealing with like, tons of dynamic data constantly changing.
Right. And it's not just about raw performance. Signals can also make your code a lot simpler, by getting rid of the need for hooks like use memo and use callback, which are often used for optimization.
Oh, interesting. I always found those hooks a bit tricky to use correctly. So can you give me an example of how signals simplify things?
Sure. Let's say you have a component that's calculating like a really complex derived value based on a few pieces of state. With traditional methods, you might use memo to kind of memoize this calculation and avoid unnecessary recomputations. But with signals, this derived value could be represented as a computed signal, which automatically keeps track of its dependencies and only recalculates when it absolutely has to.
So it's like having built-in optimization without the mental overhead of you having to manually manage the memorization process. That sounds way more elegant.
Yeah, and it's not just about elegance. This built-in optimization also leads to more predictable performance because you're not relying on these potentially error-prone manual memulation techniques.
Okay, so we've got performance gains and code simplicity. What else makes signals stand out from the crowd?
Well, another important aspect that often gets overlooked is the ability to manage global state really efficiently, using signals in combination with the context API.
Yeah, I've used context before, but I'll be honest, it can sometimes feel a bit cumbersome, especially when you're dealing with like really complex state updates. How do signals improve this?
Imagine you've got a theme switcher in your app. Traditionally, updating that theme might trigger a re-render of the entire application, even for components that aren't actually affected by the theme change.
I've seen that happen, and it can be a real performance killer.
With signals, you can actually create a signal specifically for the theme and then wrap that in a context provider. Components that need to know about the theme can then subscribe to the signal, so when the theme changes, only the components that are actually subscribed will re-render, making the updates way more efficient.
Ah, I see. So it's like signals are giving us the best of both worlds, the power to manage global state with the fine-grained control of component-level updates.
Exactly, and we're just scratching the surface of what signals can do.
I'm definitely excited to dive deeper. But before we move on to the more complex examples, I want to make sure we're all on the same page here. Can you give a brief overview of how signals actually work under the hood? Like what's going on behind the scenes?
Sure. So at their core, signals use a mechanism called dependency tracking. Each signal keeps track of which parts of the code depend on its value. And then, when a signal's value changes, it notifies all of its dependents, triggering updates only in those specific parts of the code.
So it's like a network of these interconnected signals where changes kind of intelligently propagate through the system, only updating what needs to be updated.
Exactly. And this dependency tracking is what allows signals to achieve those granular updates and performance optimizations we've been talking about.
That makes a lot of sense. Now that we've laid the foundation, I'm ready to see these signals in action. Let's start with a simple example, just to get a feel for how to use them in practice.
Great idea. Why don't we build a classic counter component using signals just to illustrate the basic concepts?
I like it. I'm ready to roll up my sleeves and get coding. But before we do, are there any specific libraries we need to install to use signals?
Yeah, so as of right now, React doesn't actually natively support signals. We'll be using the @preact signals React library, which is designed specifically for integrating signals into React.
Okay, so assuming we've got that library installed and ready to go, what's our first step in building this counter component with signals?
First things first, we're going to create a signal to hold the counter value. We can do that using the signal function from the @preact signals React library.
Okay, so we're creating like a reactive container for our counter value. What do we initialize this signal with?
Let's start with a value of 0. This will be like our initial counter state.
Sounds good. So we've got our signal initialized. How do we display this counter value in the user interface?
To display the value, we simply access the signal's value property, which holds the current state of the signal.
Gotcha. So if we wanted to show the counter value in like a paragraph element, we would just render signal.value inside that paragraph.
Exactly. And because signals are reactive, any changes to the signal's value will automatically trigger an update in the UI, making sure that the displayed counter is always showing the correct current state.
This is starting to feel very intuitive.
Yeah.
But how do we actually update the counter? Like, how would we increment the counter when a button is clicked?
That's where the magic of signals really comes in. To increment the counter, we can just modify the signal's value property directly. So in our buttons on click handler, we'd write count.value plus plus.
Wait, seriously?
Yeah.
It's that simple? No need for like a special setter function or anything like that. We just directly modify the value property.
That's right. Signals handle all the update logic internally, so you can just interact directly with the state, making your code a lot cleaner and easier to read.
I'm starting to see how signals can really reduce the amount of like boilerplate code that's usually required for state management.
Yeah.
This is definitely a lot simpler than some of the approaches I've used in the past.
And we're just getting started. As we move on to some more complex examples, you'll see how signals can handle even the most intricate state interactions without breaking a sweat.
Okay, I'm definitely ready to dive into those more advanced use cases.
Yeah.
But for now, I think it's time to take a quick pause.
Sounds good. We'll be back in a moment to unleash the full power of signals.
Okay, so we're back and we're ready to, I guess, unlock the next level of React signals. What's next on our agenda here?
Well, let's talk about how signals can actually really change the way users interact with our application specifically. We could look at building a search bar that responds instantly to what the user is typing. So no more waiting for a button, click the results, just update in real time.
Reactive search. I've definitely used search bars that felt, slow and sluggish, and it's like the worst user experience.
I'm guessing signals are kind of the key to making that experience buttery smooth.
Yeah, exactly. With like traditional methods, you might be tempted to just re-render that whole results list every time somebody presses a key, but that's like super inefficient. Signals let us be way more targeted in our approach.
Okay, so how do we approach this with signals? Would we create like a separate signal for every single search result?
Not quite. We'd have one signal that stores the user's search query. Think of it as like the input that drives the entire search logic.
Okay, so every time the user types a letter, this query signal gets updated.
Precisely. And this is where we can leverage the power of those computed signals we talked about earlier. We create a computed signal that takes this query signal as input and then filters the data based on that query to produce a list of relevant results.
So the computed signal is doing the heavy lifting, dynamically updating the results based on what's in that query signal. Very elegant and efficient. And most importantly, reactive. The beauty is that all of this happens automatically whenever that query signal changes, giving users the instant feedback they expect these days.
But let's be real, a basic reactive search is like the bare minimum these days. How can we take it up a notch? What about adding some autocomplete functionality?
Great point. And again, this is where signals really shine. We can introduce another computed signal that's specifically dedicated to generating those autocomplete suggestions using the current query as input.
So while the user's typing, we've got these two computed signals working in parallel. One's handling the actual search results, and the other is generating suggestions, right?
You got it. And to display these suggestions, we could use a drop-down or a list that's reactively bound to this new computed signal. As the suggestions change, the UI updates instantly.
I can already imagine how this would create such a smooth and intuitive search experience. The user feels like the interface is like reading their mind, suggesting relevant options before they've even finished typing.
Exactly. It's all about creating that seamless flow of information and interaction.
All right, so we've got reactive search, we've got autocomplete. What other challenges can Signals help us tackle?
Let's shift gears and think about global state management. Something as simple as a theme switcher can really benefit from using a signal-based approach.
I've used the Context API for global state, but sometimes it feels like changing one thing triggers these like unnecessary updates in parts of the app that had nothing to do with the change.
Yeah, you're absolutely right. That's because with context alone, any update to the context value can potentially trigger this cascade of re-renders across your entire app. Signals offer a much more refined solution.
I'm all ears. How do we incorporate signals into our context?
So instead of just storing a plain value in our context, we would store a signal. Let's say it's a theme signal that represents whether we're in light mode or dark mode. Components that need to know about the current theme can then subscribe to this signal.
So when a user clicks that theme toggle, we update this theme signal, and only the components that are actually subscribed to it will re-render.
Exactly. That level of granularity is what makes signals so powerful for managing global state. You avoid those unnecessary re-renders that can really slow things down.
This is starting to feel like we've got some sort of superpower. We're in complete control of our state management with this laser focus. But before we get too carried away, let's bring it back down to earth with something more concrete.
You're right. It's time to put all these concepts we've talked about into practice, with a classic example, building a to-do list application.
Love it. We can explore all the usual suspects, adding tasks, deleting tasks, updating tasks, maybe even throw in some persistence with local storage. This will be a good test for Signals.
Yeah, it'll allow us to showcase some of the more advanced techniques as well. So are you ready to build this thing?
Absolutely. Let's make this signal-powered to-do list a reality. But before we get into the code, I think it's time for another quick break.
Sounds good. We'll be back shortly to create our to-do list masterpiece, all powered by the reactive energy of Signals.
Okay, so let's actually build this to-do list app. We've been talking about all this theory. Now it's time to get our hands dirty and write some code. Where do we begin?
Well, at the core of any to-do list app is the list itself, right? So we'll start by creating a signal to hold our to-do items.
Makes sense. A signal for like the array of tasks.
Yeah.
What kind of data should each task have?
Each task will be an object, and we'll give it a few properties. The actual text of the task itself, a unique ID so we can, easily identify it, and then a Boolean to track whether it's completed or not.
Okay, so we initialize our signal with an empty array, ready for those tasks to start rolling in. How do we actually handle adding a new task to the list?
We'll create a function, let's call it add task. It'll take the task text as input, generate a unique ID for that task, and then update our Todo's signal. We'll basically append this new task object to the array.
Appending to the array, that's an important detail, right? We're not replacing the entire array every time, we're just efficiently adding to it.
Exactly. And because signals are reactive, this change will automatically be reflected in any part of our UI that's displaying that to-do list.
No need to manually trigger re-renders or anything like that.
Awesome.
So we can add tasks, but how do we delete tasks? Yeah, I got to get rid of those completed items.
Absolutely. We'll have another function called delete task. It'll take the ID of the task that needs to be deleted as input and then update the to-do signal again. But this time we'll filter out the task with the matching ID from the array.
So again, we're not directly messing with the DOM or anything. We just update the signal and the UI updates itself automatically. I like it.
Exactly. It keeps our code nice and clean and focused on the logic rather than getting lost in the weeds of DOM manipulation.
Okay, we can add tasks. We can delete tasks. What about those other common to-do list actions, like editing a task, marking it complete or incomplete?
Same concept, really. We'll have functions like update task text and toggle task completed. They'll take the task ID and then the new text or the new completion status, find the matching task in the array, and update it directly.
So it's all about efficiently modifying that Todo signal and letting that reactivity handle the updates. This is feeling so much more streamlined than some of the other state management approaches I've wrestled with in the past.
That's the power of signals. They just simplify everything, make your code more readable and easier to work with.
Now, there's one super important aspect we haven't really talked about yet, persistence, right? We don't want the user to lose their entire to-do list every time they close their browser.
Of course. For that, we'll use the trusty use effect hook. It's perfect for handling those side effects like interacting with local storage.
Okay, so inside that use effect hook, what's our strategy?
So whenever that toto signal changes, we'll save the current to-do array to local storage. Then when the component first mounts, we'll read any existing to-do data from local storage and use that to initialize the toto signal.
Ah, so it's like a two-way synchronization between our signal and local storage, always making sure the user's data is safe and sound. That's a really clean and elegant way to handle persistence.
Yeah, it keeps things simple. And with that, we've basically built a fully functional to-do list application, all powered by React signals.
You know what's amazing is that it feels like we built this really robust app, but the code itself is probably super concise and easy to understand thanks to the magic of signals.
That's the whole point. Signals let you focus on the core logic of your app, without all that extra complexity and boilerplate that often comes with state management.
So for our listeners who are, maybe just starting their journey with React signals,
Yeah.
what would you say are like the key takeaways you'd want them to remember?
Well, signals are a modern and efficient approach to handling state in React apps. And it's not just about performance, although that's a huge benefit, but they also lead to simpler, more maintainable code, which is always a good thing.
We've seen how they can be used for all sorts of things, from creating those really dynamic user interfaces to managing global state and even handling things like data persistence. And through it all, signals have helped us keep our code nice and organized and easy to follow.
Maybe the most important takeaway is that signals encourage a more declarative way of thinking about state and its connection to the UI. It's a different way of thinking.
It's not about manually updating the DOM every time something changes. It's about defining those relationships between your data and letting the reactivity of signals do all the heavy lifting for you.
Exactly. This shift in thinking can lead to much more robust and scalable applications in the long run.
Well, this has been an incredible deep dive into the world of React signals. Before we sign off, I just want to remind everyone that the journey of learning and discovery doesn't end here.
Be sure to subscribe to the All Sorts podcast on YouTube to catch all of our latest deep dives. We cover a wide range of topics from AI and blockchain to history and philosophy.
And if you're active on social media, we'd love for you to follow us on X, Instagram, and Threads. We love hearing from our listeners and engaging in thought-provoking conversations that broaden our understanding of the world.
Until next time, keep exploring, keep learning, and never let that spark of curiosity fade away.
Remember, the world is full of wonders just waiting to be discovered. Go out there and make something amazing.